So maybe let's move on to the next slide if there are no other questions. So these are things that you've already said. The generalizations about substances that do light up the light bulb, well, they all seem to involve a metal. If the compounds that have metal and nonmetal, they light up the bulb when they are dissolved in water, but not when they're solid. And the metal solids do light up the bulb. And then if we go to the next one, we have some generalizations about what does not light up the bulb. Compounds made of carbon, hydrogen, and oxygen in general don't light up the bulb. Compounds made entirely of nonmetals generally don't light up the bulb. And compounds made up of a combination of metals and nonmetals don't light up the bulb when they are in their solid form. And so on the next slide, we end this. The next slide.
Sorry, just a moment.
In the next slide, we just have these all listed out. We can place all the substances tested into one of the four categories. Notice that diamond is in blue because I substituted that for the wax. We're going to show you how that moves into the next lesson, and it's a little hard for most teachers to have some diamond in the room for the students to take a look at, but it doesn't conduct and it's insoluble. And so this is how these have divided up. All right, and then I think we're going to end this lesson. We always end with a check-in, and what we do with this check-in is our goal is not to trick the students. Our goal is to ask a question that if you understood what we were doing, you should be able to answer this question. So now I'm giving you magnesium sulfate. It's known as Epsom salt. The students would not necessarily know, and they see this formula MgSO4 aqueous. So the question is, if I had, they should know what aqueous means because we've already taught that to them. So if I tell them I have MgSO4 aqueous, will it conduct electricity? State your reasoning. And so what do you think some of the students might say? Like I said, the goal at this point is to convince them that they've actually gotten something out of the lesson. So they can look back at they can look back at what they've just done, the charts they made. Here's a new one.
And
so Leslie, one comment. Oh, go ahead, Julie.
I was going to say, here are some answers that a few people have posted in about that question, what they think the students would say. One is, yes, it has a metal. It dissolves and conducts. It would conduct because it is made of metal and nonmetal atoms. And another comment was that from Steve, he said he really likes the check-in questions because students should be able to deduce an answer. And he thinks they might say it would both dissolve and conduct electricity.
Mm-hmm. Okay, very good. So that's the kind of the pace of our lessons. We start with a chem catalyst that gets them thinking atoms are somehow stuck together or not, and that's what we're exploring. And then we do the simple tests to try to help the students gather data from which they can draw some of their own conclusions and then successfully answer a check-in. And I think we wanted to show you a little bit about how this ties into the next lesson because it's a very cool way of thinking about bonding before we get into all kinds of details about bonds. So Jeffrey, you want to say something about this?
Yeah, I wanted to just point, we'll see it a little bit later in the WebEx. Normally students would go home and they would have a student reading in the student textbook that's based on lesson 25 that they just did in class. But as Dr. Stacy said, we're going to give you a sneak preview of tomorrow's class so you can the follow-up to this particular inquiry-based lab experience. So the next lesson is called Electron Glue, and it's all about bonding. In this particular activity, students will be using a handout that you would find in the teacher resource material, a worksheet, which they would have had just, yesterday also while they did their lab. So there's usually a student worksheet that goes with each lesson. And in this particular case, there's a set of cards called the substance cards that are available in the teacher resource materials that you would be able to download and print out. And so in this particular lesson, the learning objectives are to have students define what a chemical bond is and describe 4 basic types of chemical bonds, to use chemical formulas to sort substances into bonding categories, and to predict the properties of a substance based on its chemical formula and bonding type. And so we're not going to go through the full lesson, but I did want to give you an idea of what students would see after they do their Chem Catalyst. When they move into their Explore section, they'll be using what we mentioned, the substance cards. So Dr. Stacy, maybe you can talk a little bit about these and how they're used during the class.
Yeah, so one of the things that I've always noticed about bonding is that we very carefully delve right into a covalent bond. Then we talk about an ionic bond. And what I was finding with my students is they just weren't seeing the general patterns. And what I would like them to be able to do is if I give them a chemical formula, that they can actually say, aha, I'll bet you that this substance has these kinds of properties. And so that's what we're trying to build for before we get into too many of the details, so really look for general patterns. And so we give them these substance cards. And you can see they're ones that we just looked at in this last lesson. So there's water, and it shows that it does not conduct. There's silicon, so we're showing them some new ones now. And silicon is a hard solid. Here's one that's actually an element, an elemental nonmetal, although it's right at the boundary. It really doesn't dissolve. It certainly doesn't dissolve because otherwise your computer would dissolve. And it sometimes conducts. And so you see we've given mercury. It's a liquid. It doesn't dissolve. It does conduct. And there's about, how many are there? There's 16 of these cards. And we ask the students just to sort the cards because we're trying to reinforce the things that we did before. And the goal would be to sort them based on the same categories that we just looked at, but now they're doing it with these cards. All right, now what they're doing with the cards in addition is to look at where the electrons are. And this is a very important image that we use, 4 images here, where the red circles are meant to be the atoms in the substance, and the blue shading is meant to show you where the electrons are. So in the metallic substance, the blue shading is trying to indicate that the electrons are kind of spread out all over the place. In what we call network covalent, the electrons are very rigidly held between the atoms. In molecular covalent, they're held between atoms too, but not between all of the atoms. And then for ionic, the electrons have actually moved to one type of atom and they're not on the other atoms. Okay? And what the students are then working towards understanding is that when the electrons are spread out in aluminum and it's metallic, the ones that are insoluble and don't have electrons that are between all the atoms in this rigid network, and we call that network covalent. This is silicon dioxide and carbon. How that differs from molecular covalent is the electrons are holding little clusters of atoms together, but they're not holding all of the atoms together. So water can actually disperse the clusters of molecules and get them to move throughout the solution or throughout the liquid, whereas they can't when they're network covalent because all of the atoms are connected so rigidly to one another. And then when we look at ionic, we see that the electrons have moved on to some and not on to others. And like I said, we're going to get into all of these in more detail. We're just trying to get a general overview out. And we have ones that, again, that's dissolved. Now, what's interesting about these models and what we show is we really want to emphasize relating macroscopic properties with these visual representations of what the atoms are doing and where the bonds are, where the electrons are, how these atoms are glued together. And in the student book, we actually show what happens when we dissolve in water for each of these bonding types. But let me show you another cute cartoon.